Hey everybody, I'm Rashid. So I'll continue the review for inverse functions. Probably you won't see the previous examples in a previous video. And for this one, it's a little bit difficult compared to the previous examples. So the first step, g of x is called y. Then second step, which is the important step, is the interchange x and y. So which means the x will take the place of y and y will take the place of x. And the previous video I explained why we need the interchange, right? And the third step, we're gonna, since we start with y, we need to end with y, which means we need to solve for y. So we're gonna put a 1 here. These x multiply, cross multiply by 7y plus 3, it equals to a 6y minus 7 times 1, which is just the same. Then we distribute a 7xy plus 3x equal a 6y minus a 7. Since we're interested in the y terms, then we need to have them together. So 7xy, we subtract the 6y both sides. Then it's going to become minus 6y plus 3x equal -7. Now, this is important. You've done something in the past that's like 2x plus 3y equal, let's say, 6. Then for a line, and you're trying to isolate y. So when that first step, you probably used to the idea that you need to subtract 2x. So instead of writing it just 6 minus 2x, you just do it, you skip that step by saying, I need to subtract 2x, and you put it at the front. So I'll do the same thing here. Instead of doing -7 minus 3x, which is fine, then you need to switch it, or we just use that same idea, shows that it applies here. 7xy minus 6y. All right. So this example requires few things, unlike the other ones. We still don't have y by itself. These are not like terms, so you can say a 7 minus a 6, there is an x there. So anytime this is, we're stuck in this, but y is common, so we can just factor out or factor this GCF, or greatest common factor. In this case, it's just y. All right. Then y multiplied by whatever quantity. So you used to, if you have this, you multiply by 2 both sides to get x by itself. It's same thing here. We'll divide by this quantity here, 7x minus 6, so it goes away. Then when you have y by itself, that's the final step. We're going to call it the inverse function, 7x minus 6. So this goes from a domain, and this inverse goes back from its domain, or from the range of this function. So I explained this in the previous video, and you can see it. So now we answered this part. If we call this A, we answered A. And this now needs the domain and range of the inverse. So there are two styles. Either to find these before, like answer B before A, which is possible, using the idea stated in the previous video, or now that you have it, you're gonna say, if I want to graph these inverse, you know, to have an idea about the domain and range, if we don't see it there, maybe we need to graph the function and have that visual effect to it. So if I want to graph this thing based on, prior to this, you've done a graph of rational functions. So you looked at the vertical asymptote from the, and of course there are some previous videos I did exactly something like this. So vertical asymptotes, or asymptote here is just one. It's going to be 7x minus 6 equals 0, x equal add 6 and divided by 7. So this function here, if we were to graph it, let's do it here. Six is a positive number, let's say it's here. Right. So that's the vertical asymptote. Now, does it have a slant? Does it have horizontal? All this will come up from looking at the degree of the top and the bottom. And since they're the same, there is a horizontal asymptote at given at these front numbers, which is, since it's a horizontal, the equation is going to be y, not x, negative 3/7. So it's a negative number, and we'll say negative 3/7, let's say it's here. So this gives you a frame for the graph. The graph is going to come here from left, and it's not going to intersect this 6/7, this vertical asymptote. You would have to kind of jump it. So the domain of the function, or maybe we can show it this way. So the graph, because we're looking at x from negative infinity to positive infinity, so the graph will go from negative infinity to 6/7. Then it will have to disconnect there and start here. So that's where we're going to put those parentheses and say negative infinity to 6/7 for the domain. So let's write it down. So the domain of the inverse is going to be negative infinity to 6/7, skipping or not including 6/7 to infinity. The range will do the same thing when it comes to this. Of course, there are some questions that the graph can still intersect the horizontal, but in this video, we're not going to try to prove that, that it's not intersecting it and skipping it, but we can do that. We can do that, but in this example, it's not. And we will show as well, I will show as well what's going on, why we are certain about that. So if you look here, it comes to this horizontal asymptote, and you know, the graph, I'm not graphing it, but I'm just giving you the idea that now that we have the asymptotes, what's going on. So yeah, so we can write the same thing, that it's going to start from this negative infinity up to this number, not including this number, and from there again it's going to keep going towards infinity. So the range of the inverse is negative infinity to negative 3/7. And of course, the domain, we're looking at x, and the range we're looking at the y's. And I'm not putting brackets and numbers because it means exclude, not include. If you put brackets, it won't make sense, you know, that you're including the number twice. which means, okay. So this is now one way. And to verify whether this is correct or not, we can also look at the original function. Here is the original function. Let's look at it. If you look at the previous video and by now and understand the inverse functions, then you will keep in mind that relationship. So if we look at this inverse function here, then the domain, its domain, the domain of G, can you set this denominator to 0, it's going to be negative 3/7 that makes the denominator 0. So you're going to skip negative 3/7 for the domain. And based on previous talk, this domain of the function is going to be exactly the range of the inverse, right? So let's check if that's what we found. The range of the inverse is negative infinity to negative 3/7, so exactly the same thing. All right. And now let's look at this graph, if you, or function, if you graph it, it also has this 6/7. So which also same thing, if you do 6/7 here, it's that disconnect. So the range of the function, same thing, if you're trying to graph it, it's going to be which is the same as the domain of the inverse. And yeah, that's it. So there are two ways to find this thing. And I can do a different video to prove that these things don't intersect, you know, the horizontal asymptote for here, because it is possible. I think that's it. So we answered the first question, which is here. We look at the denominator, we took out 6/7, right? Took out 6/7. We looked at the front numbers, we took them out from the range. That's it.